Shall I proceed?
Yes.
Okay, sir. Good morning, ladies and gentlemen. So, first of all, we are going to focus, and this presentation is focused completely on coaches centric. The purpose of the presentation is to bridge the gap between the researcher and practitioner. In specific, now in this contest, we are trying to connect the biomechanists and coaches, so how we can move forward further. And as Dr. Sadhu said, I completed my diploma in coaching, NIS Bangalore from 2010 batch. So in the next 5 years, I had the opportunity to work with different aspects and different capacity in the coaching area. And then I shifted as a sports biomechanist in Malaysia. So I can personally understand the strength and weaknesses of the coaches community and the strength and weaknesses of the scientific community. So I'm here to connect and how to move forward further, and I will try to address all the strengths and weaknesses and try to match everything perfectly. So when it comes to sports science, everybody is focusing on evidence-based approach. All the sports scientists will work on research and facts. All the measurements should be taken in an accurate way. But in terms of coaches' perspective, all the coaches will be on practice-based approach. So their focus is only on results and performance. And they are highly works on their instinct and feel. So that is the key difference between the sports scientists and coaches. And what is the really lacking behind us is sports scientists is having a lack of communication with the coaches in terms of jargons, which means the words which the scientist uses in the coaching community is not user friendly. So when the scientists come down, and then if the scientists can able to translate all the information in the plain language, is a user friendly language, so the coaches can able to understand and they can able to implement in the coaching field. And what is the drawback in the coaching field is coaches are like very inconsistent in understanding the biomechanical theories. So I will try to address that to understand some of the biomechanical theories. And the second most important thing is the coaches should understand what are the support services during the training and competition can be utilized from the scientific community, especially from the biomechanics perspective. So we will go through one by one. So since our topic is focusing on high performance sports, so let us discuss what is high performance sports first. Have a look at the video from 1916 and 2016. So in 100 years of time, you can visualize so much of differences in the field. You can see like in 1912, they have completed in with 10.80 seconds, and it's around 9.61 seconds. So that is the difference. But what is the scientific community made an effort of 1912 and so in over of these 100 years, you can see that you can able to reduce only 2016 timing is like plotted in 131 position. So imagine how the complete sporting community has improved a lot. And when you compare the top 3 athletes, they are less than 90 seconds, which is a 1% difference between the athletes. So we are now focusing on that 1% of the performance, which is elite and high performance sports. So all the coaches need to work on that 1%. So to make it more clearer, I have given another example from 2016. Um, in drawing, this is a final event between the New Zealand and Croatia. So they are trying to compete. So now you can see here. Can you able to see the difference? Who is the winner? It's quite very difficult to identify that. So, the event ended with the photo finish. You can see it's very minute. So the difference is less than 0.01 percentage. The performance was very minute. So we need to work on that. So 2019, a indoor cycling event, the difference between the gold and the silver is, imagine the percentage of difference between the gold and silver. So in accordance with the sports science and coaching, so we have to work towards the 1% difference to win the gold medal or the silver medal. So with the support of coaching community, all the sports science like biomechanics, strength and conditioning, nutrition, physiology, and psychology, everyone is supporting the coaching community to enhance the performance. So in this presentation, we are focusing on sports biomechanics. So in general, the sports biomechanics is really focusing on enhancing the performance and injury prevention. That is the key and major goal of the sports biomechanics. And the second objective is for the rehabilitation, which is the clinical biomechanics, where we can minimize the injury or we can return to sports, how we can able to analyze some of the clinical aspects. Excuse me. So the last one is to design an effective training method. So these are the three principles which we need to work towards a sports biomechanics. So since I understood some of the strengths and weaknesses of both the community, so I take an approach to make the concepts biomechanics simplified for the coaches. So why do we need a biomechanics for sports coaching? I will give a small question for all the coaches. So here, can you able to find how many F, leave this F and try to find how many F in these lines so that we can able to, so you can give a message in the chat box, or I will give like 20 seconds to read that. Have a read all these lines, try to identify how many F in this sentence. Any comments, sir, from the chat box? Okay, so the answer is 6. I don't know how many has got the exact answer 6, but you can see there are so many F in the sentence, and I'm sure that only very few coaches can able to get the answer 6. And the reason is because our brain is already trained to look at few things, and something will be addressed and something will be missed. So to address everything, so we need some kind of technology, some kind of biomechanic support for the coaches to address all the information. So there is another question for coaches. How I will just give a Q and C, just a small word, a letter. You guys should just remember this and then try to recollect. You can able to recollect the complete letters or not. So I will give for 1 second or 2 seconds, and then I will move further. Try to recollect. If it is not, then we can understand what is the reason. So try to repeat the letters by yourself, and then I will give the second. You can repeat yourself. The third, I'll give you 3 seconds. So I hope the first 3-letter word is going to be very simple, and 6-letter word is going to be very simple for all the coaches, and the 8-letter word is going to be very difficult to recollect the information. Because our memory is trained in such a way, we can able to recollect only the 6 points of information, 6 bits of information. That is why we have the pin code of 6 numbers. We have the password of 4 numbers in the ATM pin. So what is the reason? So only our human brain has a capacity to have a memory of 6 bits. So, and in this, you can see because of the trained memory, most of the coaches might not achieve that exact number. And because of the short-term memory, so the information will be deleted automatically. So that is the reason why we need biomechanics in the coaching community to support the coaches to identify the bits and bits of information in a detailed manner to address and for enhancement of the performance. So to address the basic concepts, all the coaches first need to understand. So in high performance, the analysis will be done either based on video, infrared cameras, or catapult system, which kind of GPS system. So all the system, we will able to retrieve only the position data. The position data is where we stand in respect to time in that particular space. So at the end, we can able to get the complete time information and complete amount of what is the amount of movement in the body. So from there, if you plot the graph in respect position is a time graph, with this information, we can able to identify the distance, displacement, how far the athlete traveled, speed and velocity, how fast the athlete traveled. And with that position time graph, if you plot that information in the velocity versus time graph, so the coaches can able to understand how fast the athlete is trying to change the position, where we can able to get the acceleration of an athlete. If you again plot the acceleration data versus time, and you can really get the deeper information how fast the athlete can able to jerk. So usually, colloquially, we'll be using the term jerk. So how far and how quick we are trying to change. So with the help of a basic camera or infrared cameras, we can able to get all the information. So with this one slide, I can able to translate all the kinematic parameters for you to better understanding. And the second one is the Newton's law. So imagine that the ball is stationary. So without any external force, the ball will not move and ball is going to be rest. So that's the first Newton law of inertia. And if I'm playing now, it is Newton's second law of acceleration. And imagine that the ball hits the wall and return back to us, so which is law of action and reaction. So in one example, I try to understand, and coaches can able to implement this kind of law in your sports. So the next one is momentum. You try to visualize the this athlete. So imagine that this mass of the athlete is going to be 100. Both the athletes going to be 100, but so one of the athlete is having a higher velocity of running towards the other one. So you imagine that he is coming with 7 meters per second and another one is 9 meters per second. So the athlete tends to move towards the athlete who is in the direction of 7 meters per second. So you can see here, if the athlete is having a higher stability, he can able to reduce that, he can able to resist that speed. That's how the momentum and stability works. And the next concept is on impact and coefficient of restitution. Whenever we release the ball, there will be a kind of, imagine this is the initial velocity and it won't come back to the actual position. So this final position is where the energy is lost. So that energy is known as the coefficient of restitution. So understand the work and power in this. So this is the isokinetic dynamometer. We know what is the exact length from here to here, and with the system we know what is the amount of force, and we know what is the distance, what is the range of movement. So with this information we can able to calculate the work and power. So the torque is one of the most key important point for the coaches to increase the intensity of an exercise athlete. So imagine that the athlete is performing a lateral dumbbell rise, so there is no bend in the elbow. So imagine the line of force is here and the axis of rotation is here. So this, if the axis and the force, the distance is higher, the intensity is higher. So if the players want to reduce the intensity, they can make the elbow bend and then they can able to perform the same lateral rise. So the intensity is going to be less. So this is the difference and how the coaches can really implement the biomechanics during the training. And the next concept is the moment of inertia. So imagine this axis. So if that diver wants to rotate faster, the moment of inertia should be less, which is they need to be tucked in position. When they release their hand, so then the moment of inertia is going to be high, then the speed is going to be less. So that is the relationship between the axis of rotation. And the importance of center of mass in relation to irrespective of sports is more important. So everyone knows the Frostbury fob, which is giving the most important dominant information for us. So in this, you can see the center of gravity is lower than the bar. So that is how the athlete is trying to achieve higher and higher level in the high jump. And it can be implemented in all sports and all type of skills where the center of mass is more important for us. And the last concept is the ground reaction force, where for this we need some kind of force plate or load source. With this information, we can able to identify what is the amount of load has been implemented in the foot or in the knee or hip. So that information is going to be much more benefited for the coaches. So with this, I have covered almost most of the concepts, which is simple, and I try to simplify all the concepts specifically for the coaches. And now I will try to explain how we are approaching in National Sports Institute of Malaysia in each and every aspect, in terms of clinical biomechanics, in terms of high performance, in terms of identifying an issue. So we can go one by one. As a coach, can you able to visualize any kind of changes in this? So the athlete came up with the complaint of having a right lateral thigh calfness. So there is a tightness in the calf for the athlete. So is the coaches can able to identify, is there any mistakes or is there any issues in the running pattern? So that is going to be the first impact. So coaches need to visualize a lot of videos, and it's very difficult when the athlete is running in a normal running speed. But when I try to minimize the speed of the video, if we are trying to visualize that in the slow motion, where comes the qualitative analysis? Here, you can see how the athlete is moving. So the athlete is trying to take the knee laterally outside. And here you can see there is excess of pronation in the foot. Try to watch the right foot here. Is that you can see there is an excess of pronation, there is a shank rotation, and where the coaches can able to visually classify and identify some of the information. And from there, we have analyzed in depth using a motion capture analysis, and we have analyzed through a visual 3D software to get a deeper information of the athlete. So the first information that we can get able to is, you can see there is a step length, stride length, stance time. So even though the athlete is having any kind of pain, you can see there is no difference in the parameters. There is no difference in the stride length. There is no difference in the step length. So what is the issue? So going forward, you can see, imagine that in the right knee angle. So when the information is below 0, which means the knee is going outward. If the data is going up, which means knee is moving inward. So I'm trying to simplify the contest. So whenever the athlete is trying to run, he is trying to take his foot outward and then he's trying to move in. So there is a pattern he is following. So that is the first issue. And the second issue is you can see the shank rotation here. So the athlete is trying to tend to move the shank towards medial, which is inward every time. So the knee is moving outward and the shank is moving inward. So there is a kind of a torsion effect takes place. And the third information is, you can see there is a limitation of range of motion in the ankle joint where the athlete moves down and forward up. So with this three information, we can able to conclude that, so this is the cause of an athlete where the right side lateral cuff is got tightness. So what is the implication? So the biomechanics will not work stand alone. So it will work in collaboration with the other sports science in like physiotherapy or sports medicine or strength and conditioning. So in this aspect, in terms of clinical biomechanics, so we need to work with the physiotherapist where we can do some kind of taping, some kind of rehabilitation, and further we can go some kind of rehabilitation exercises. So with that, we can able to minimize the load in the joint. So that's the first aspect. And this is the another information where the athlete is trying to tilt his trunk towards the right and left. So this is another information. So the concept here is when you work with the physiotherapy and then you can follow with what kind of clinical aspect we can able to reduce. So as a biomechanist, we need to convey the information to the coaches and the medical professionals where is the key identification where the issue is going to be. And this is the second example where we take a mathematical modeling as an approach. We take one athlete as an example. So as a coach, you can visualize, we can plot the athlete's information from 2012 to 2019. So we started our so many interventions in the year of 2015 and 16. So the reason behind is you can see there is a plateau in the performance. So there is no increase in the performance. So that is why we have implemented a different approach to address that. So the first step is, so we analyze the athlete. So his angle of release where he is releasing is 31 degree and his performance was increase the angle from 31 implemented that in the athletes by from the less angle to the higher angle. You can see the difference from this is during the training. So during training from 14 to 15, so 1 meter difference is going to be really impactful. So again, you can see with that information, so athlete got a gold medal in 2016 Rio. And we are trying to take another approach for the another subsequent world record of 17.29 meters. For that, what we have did is we try to increase the velocity of a release. So we try to model the performance again. So here you can see this is the angle of release, and this is the angle of release, and this is the performance. So with this angle of release, around 35, 37, you can see we can go up to 20 meters. So this is the information. So 30 meters is not logical, but we try to mathematically mod all the information for the easier purpose. So what we did is we try to increase the velocity of an athlete. So we mathematically model the information. So what happens, what is the maximum force the athlete can able to generate when he can able to throw with 11 meters per second. So when you see here, this is the maximum force as the velocity increases. As the velocity increases, the force of release is increased. So if the force increases, eventually the power of release is increases. In turn, we can able to increase the performance of an individual. So what we did, so our approach of mathematical modeling is like realistic. So our mathematical modeling, whatever mathematical modeling we do, it should be more realistic. So we try to improve 13 meters per second, and we can able to achieve some better performance in future. So in addition to the kinematic analysis, we try to do motion capture analysis to get the deeper understanding of the movement. So we need to understand what is the real cause of, what is the real key factor in relation to the performance, where we can able to further tweak and improve the performance. So further, again, we completely analyzed in the software Visual 3D. And then what we got here is the critical factors. And I've differentiated with the different key phases. And in this phase, the rear knee angle is the key factor. And in the factor where we can able to generate a more force, and the shoulder velocity is the second factor where we can able to implement a better. So that shoulder velocity directly relation to the shot velocity. So for the coaches, for the better understanding of what is X factor is, so when you see from the top view, the pelvis will be rotating towards the right, and the trunk will be rotating towards the right, left. So something like there is a twist in the body. So we can able to calculate how much amount of twist is needed. So if the body is rotated higher, the force is going to be higher. So that is X factor. So how do the coaches and players know whether they are throwing? So as a scientist, we are saying that to the player, so you are throwing in 31 degree and then you need to throw in 39 degree. How do the coaches and players know that whether they are throwing exactly in 31 or 39? So there is a sensor called TrackMan where you can able to instantly track what is the angle and release speed, but most of the places that is more expensive tool is very difficult to get that such kind of softwares or technology. So what I did is I developed a kind of small application in the MATLAB. So here you can see, so the first thing is the better performance, and the second one is the lower performance. So here you can see the difference between the video 1 and video 2. So what I did is, so I'm trying to compare the video, and then I'm trying to give what is the ratio between the first best performance and the second performance. So from there, coaches can able to visualize what is the angle and what is the difference between the first trial and the second trial. So coaches and the athletes need some kind of visual information to see what is the differences there between the performances. So this is the approach we have taken. And the second thing is, what are the key factors contributing for the elite jumping smash? So this is the biomechanics laboratory in ISN. So what we did is the athlete is trying to jump and then take the jump smash, and then there will be an accuracy area, and then we are trying to identify the key factors which really influences the badminton jumping smash. So we again analyze the information, deeper information from the different softwares. To simplify the information, the coaches need to understand that there will be a shoulder elevation. So the shoulder elevation is the key factor, and internal rotation, which is direction towards the it, and elbow extension when you extend the elbow, and the fourth factor is the racket head speed. So these are the four key factors from the scientific community. So we analyzed, we researched, and then we identified this kind of information to the coaches. So when the coaches address the key factors, only these key factors, so they can able to enhance the performance. So that is the approach we need to take. So here is an example. What happened? What is the difference between the best smash and the fastest smash and the slowest smash? So there should be some kind of difference. So we need to make it visually so that the coaches can able to understand better. So till here there is no difference. So the difference will start now. So here you can see. So what I explained is, so this is the lateral view, which is the side view. This is the extension where you can, this is the shoulder elevation. Now this racket is in the shoulder internal rotation. This is towards the towards attacking the shuttle. So this is the difference, key difference for the fastest smash and the slowest smash. And further you can see, so that's the key difference between the fastest and the slowest smash. So the coaches should understand, and they need to visualize where to see and what to see, so that they can able to classify the information and provide feedback to the athletes. So the last example is we are trying to identify what is the cause. So initially we try to approach in the clinical perspective and the performance perspective, and now we need to identify what is the factor really lacking behind. So what is the factor? So the athlete came, so she cannot able to recover back quickly from the badminton smash lunges. So for that we did a EMG analysis. So what is EMG? So for the simpler understanding, there will be a placement of an electrode here in the hand or any kind of body. So with the sensor, we can able to retrieve the information. What we can able to retrieve is what is the amount of amplitude, what is the amount of activity we are generating. So that is the information we can able to get from EMG, which is electromyography. So whenever we perform any activity, there will be kind of muscle activation. So now with this system, we are trying to quantify that muscle. So in this example, in this contest, what we have did is we have placed the EMG in gluteus maximus, and which is the glute muscle, and in the quadriceps muscle, which is the front thigh muscle. So we have placed, so basically when you perform lunges, so the key activation of the muscle will be the glute and the front thigh muscles. So what is the difference? So when we identify, it will be there any difference? So when we compare between the left and right, there is no difference. So the athlete is completely normal, but still athlete is unable to recover back quickly. So we need to identify what is the cause. So for that, what we did is we take an approach of isokinetic testing. So in that, what we did is we use a method called isometric, which means the athlete will not move, and then the athlete will remain in this 90-degree angle or 60-degree angle and 30-degree angle. So the angle will be fixed, and then the athlete will be asked to push maximum. So here is the result. So if you see here, this is a 60-degree angle. However, means the utilization of the front thigh muscle. When you compare the left and right side, the deficit is 30%. So the left, since it is she is the right-hander, so she tends to go with the left hand lunge many times. So left lunges in the 60 degree itself, there is a deficit of 30%. And when we proceed with 45% so you can see a drastic difference. That is a difference of 68% difference between the right and left. The key information is when you still further go down to the 30 degree, you can see there is a 70% difference. So the athlete cannot unable to recover from the lunges position is because of this. So athlete, when they lunges, so they cannot able to recover back quickly. Okay, so here you can see when they lunge first, both the force plate are same, but when they retrieve back, the athlete can the green one is the after training and the white one is before training. So the white one is like before training where the athlete tends to remain in the same position, and the green one can able to retrieve faster. So that is how we identify the issue, and then we try to address in collaboration with the strength and conditioning. We address that last 30 degree of angle, so we strengthen that, and then we try to implement again, we tested again, and then we can able to see there is a difference in the training, and so now the athlete can able to recover better, and then they can go for the further action in the badminton smash or any kind of technique. So that is the identification thing. Okay, so I hope I have explained the complete information in the different perspective. So now what coaches need to do? So the first thing is the qualitative analysis. All the coaches must implement a qualitative analysis during the training session. So these are the free resources. The above one is the Technique app. Any iOS Apple users, they can use this Technique app, and any Android users, they can use the Coach's Eye to analyze all the information. So this is the standardized model for the qualitative analysis. We need to prepare what we are going to analyze and observe that what is the key information we need to analyze and evaluate and diagnose. So from the coaching perspective, you can evaluate and give a kind of information to the athletes, and then provide an intervention from the coaching perspective, and again analyze the same process again and again till achieve the best or the efficient technique. So this is the coaches, from the coaches perspective. So minimum we have to do some qualitative analysis, and further the coaches should understand some kind of quantitative analysis. What are the technologies available in the market, so that coaches can able to demand the information from the sports scientist, specifically from the biomechanical perspective. So each information provide different kind of information for the analysis perspective. In terms of video analysis and motion capture, it will give a position information where you can go for the deeper kinematics and kinetic change. And the force plate provides what is the amount of force the athlete is generating. The TrackMan is a kind of sensor where it provides the velocity and angle of release for the golf, shot put, some kind of technologies is available for different sports. And EMG, electromyography, where the amount of muscle activity has been done in particular event. IMU sensors, the IMU is a kind of a small sensor where we can able to analyze similar to the motion capture. And Kinect is a small device where we can able to visualize the information from the single camera. So coaches should understand the basic information so that the coaches can able to demand from the sports scientist and for the betterment of the performance. Okay, so so far what we have done is we have collected all the information from the athletes during the training and competition, and we will provide the feedback to the coaches and athletes. So that is what's done so far. What if during competition, how the coaches can provide a real-time feedback? So first, the clinical aspect. The first step is the thermal imaging. So we need to understand whether the athlete is going to be prone to injury or not. So in the thermal imaging, we can able to identify. So you can see here the athlete having the red zone is having the higher heat generation from the body. The yellow is the still higher. So you can still classify what is the amount of skin temperature, and from there we can able to classify the load. And here is an example from the badminton. So here you can visually see the athlete's body is turned red. Here you can see the color graph as the red is a high skin temperature. So the yellow is the still more higher skin temperature. So the complete body is like so much of heat is generating, and we can able to visually see complete blood vessels from the camera, and they can see which part of the body is utilized a lot, and from there the coaches can provide the recovery method to the athletes to minimize the injury. So even during the rest period, even during the substitution, so the coaches can use this simple technology to classify that, and then the results will be instant, and then we can provide a better feedback to the athletes with this kind of information. Aspect. So Alibaba technology has come up with a very tremendous input. So image processing, which is markerless technology, what information coaches need in real time. So maybe in the first trial, they perform with the, for example, the rotation speed is 170 degree. So the coaches need to tweak that information. So the coaches will get the information in the mobile in instant, and then they can tweak and they can give provide a feedback to the athletes. And then the second trial or third trial can be implemented better. So that is the most important aspect. So even though we are doing a post-processing, the real-time feedback is much more important for the athletes during competition. So final, what are the common mistakes by the coaches? So in specific, coaches will try to compare the performance with the elite athletes immediately without having a deeper understanding. And the coaches will always be the result oriented, and the third one will be the lack of resources in sports science for the coaches. So these are the most common mistakes they feel. So the first thing is comparing the performance. So this is the one of the US Olympic athlete. So with this software, we can able to quantify. So we can mathematically model the athlete, and then we can say what is the key difference between the actual running and the model. So when we blindly take the performance of any of the athlete, there will be an error. So we know. So for example, the athlete USAIN Bolt is tall, and one of our athlete is going to be like short. So we cannot compare the information. So for that, we need to be subject specific. So here you can see we need to create a model to the subject specific, but we need to take the characteristics and the attributes of an athlete, the elite athlete. For example, from the USAIN Bolt, we know that the ground contact time is very less. So we take that information, we take that attribute, and then we create a mathematical modeling subject to this specific, and then we can try to implement that so that there will not be any flaws in comparing the performance. So we have to take that approach for the better performance. And the result oriented, so to me, like we should focus on the process, not on the outcome. So the process is most important in the high performance sports. So if I ask everyone who is the fastest man, everyone knows the Usain Bolt. Sorry. So everyone knows the Usain Bolt. So the first step is the talent identification. So Usain Bolt started in the age of 12 years. The cricket coach identified his talent, and then he transformed from cricket to the athletics. So in 14 years, he debuted in international, and then he started high performance training in the age of 14. And then in the age of 17, he entered Olympics. And then 2016, he got 8 gold in Olympics. So this is the process. So all the coaches should understand the process. We cannot break the process. If this process is perfect, the end product will be better. So we need to focus on the process, not the outcome. So have a better understanding what are the flaws even Usain Bolt has made when at the age of 17 when he was debuted. So he is not the gold medalist, but you can still see the athlete is at the back. You can see his head is tilted back. Now you can imagine his center of mass is falling back. So when you compare the other athletes, you can see the center of mass is falling forward. So even a small bit of information is going to be very impactful. And in 4 years of time, from 21 to he has dropped down to 19.3. That's where the high performance support comes in. So imagine that whatever he trains in high performance from 2008 to 2017, he cannot able to achieve his own best performance, which is happened in 2009, 9.58 seconds. So that is most important thing. So when we visualize the 9.58 second performance in the athlete Usain Bolt, you can visually see that he is not having a proper arm action. He is literally reduced his complete kinematics, but still he can able to achieve the performance. With this information, we can visually know that he can further go, but he cannot achieve that because of different factors influence the performance. So not only the height, that might be a many cause of anthropometric parameters. It might be the cause of muscle fiber. It can be the cause of kinematical information. So that might be a most information, but we need to focus on the process. So if the process